Light. Its presence makes human sight possible. Yet its resplendent, dynamic nature taxes our optical abilities. Transitions Optical is proud to announce another innovative solution. Transitions Vantage, the next first in optical technology. The new breakthrough Transitions Vantage technology is inspired in part by the extraordinary visual abilities found in other species. Monarch butterflies use polarized light to guide them on epic 1,500-mile migrations. Ultraviolet photoreceptors in their eyes can detect the direction of polarized light waves emanating from the sun. These are the same light waves that often diminish human perception. Light is comprised of waves of various lengths, vibrating in all directions. Polarized light is composed of a high concentration of horizontal light waves. Bright light reflecting from surfaces may become polarized and appear to the human eye as glare. But research shows that monarch butterflies would be lost without it. Polarized light may also have been an important directional tool for Viking explorers. When overcast skies made navigation by the sun impossible, some historians believe Vikings used the polarizing properties of crystal sunstones to traverse the high seas. The stones turn from a subtle blue to a soft yellow when illuminated by polarized rays, giving Vikings a fix on the sun's position in the sky. It would be centuries before the power of polarization could be applied to lens technology. The need to minimize glare for military aviators led to the first polarized spectacle lenses in the years preceding World War II. Interest in sunglasses as a fashion statement began in the 1960s and is still going strong. The drawback, of course, is that the tint that is most appropriate out of doors is far less helpful indoors. The turbulent 60s also provided the first photochromic glass lenses. These lenses darkened outdoors and cleared indoors. Throughout the 70s and 80s, glass lenses were increasingly replaced by lightweight, impact-resistant plastics. In 1990, Transitions Optical was formed. The following year, it launched the first of many commercially successful plastic photochromic lenses. These advanced dynamic photochromic lenses clear and darken outside as the amount of light varies. The molecules within the lens actually change structure in response to ultraviolet rays. In addition to blocking 100% of damaging UV light, photochromic lenses reduce eye strain and eye fatigue. Sudden exposure to bright light forces the muscles of the eyes to respond quickly. Squinting is an automatic protective response. Bright light enters the human eye through the cornea. The muscles of the iris adjust the size of the pupil to regulate the amount of light. Pupil size can change from 2 to 8 millimeters, altering the amount of light by 30 times. The eye's lens focuses light waves to the retina onto tiny rods and cones. Adapting to changing light conditions, especially bright sunlight, and viewing objects at different distances, combine to tire the eye, like an extreme workout for a weekend athlete. Transitions photochromic lenses adjust the intensity of light entering the eyes. This assists their natural adaptation mechanisms, allowing for better visual sensitivity under all lighting conditions. Luminance and color contrast, therefore, are enhanced. The Transitions optical team of accomplished researchers and developers continues to innovate new, more complex dyes and applications. When added to sunwear, photochromics allow for performance sunglasses that change color and darkness in response to changing light conditions. Dynamic sunwear makes outdoor activity safer and easier on the eyes. Transitions performance sunwear adjusts from dark to darker with a range of options adapted to specific outdoor activities. The next first in lens evolution to be unveiled here today derived inspiration from creatures of the deep. Oceanographers know that light becomes highly polarized as it reaches into the ocean depths, particularly at sunset. Scientists are now learning that some cephalopods can actively control the polarization of light. The European cuttlefish is a kind of 10-armed chameleon. These amazing creatures have polarized patterns in the skin that adapt their physical appearance for specific activities. Giant squid, it is theorized, may use polarized light to spot tasty plankton that is transparent to normal vision. Humans would greatly benefit from a similar ability to dynamically alter polarization. The next first is variable polarization. The new Transitions Vantage lens makes the impossible possible. These breakthrough lenses control glare and light scatter by both darkening and controlling polarization. Clear to dark and dark to clear are no longer the only variables. Conventionally polarized lenses reduce glare by the use of fixed horizontal lines to block many of these rays. Light, polarized by reflection, can overwhelm the eye and reduce retinal sensitivity, interfering with normal vision. Transitions Vantage lenses use photochromic dyes that activate to reduce glare through variable polarization and darkness. This variable polarization reduces glare that can obscure color and detail. Transitions Vantage lenses offer the most sophisticated optical experience available today. Indoors, the lenses are virtually clear. Outdoors, they darken and polarize in response to the environment. The result: sharper image definition and enhanced contrast perception in sunshine. Transitions Vantage lenses are a clear lens replacement, so patients may still require a pair of sunglasses. So who can benefit from this dynamic new technology? Anyone who appreciates visual detail and clarity, indoors and out. In other words, those who seek a vivid, complete, and engaging visual connection to the world around them. Transitions Vantage lenses, the next first